I am the student of MIT Academy of Engineering, and under the course of Electronic Circuits and Application, we are having a group project titled Light Activated Switch using LDR and opamp comparator. So I am Ritesh Asole from A Division with PRN 202301060014, batch A4. I am having Keshav with me. So our project is light activated switch using LDR and op-amp comparator. So our aim is to design and simulate the light activated switch circuit using op-amp comparator and LDR. When we the real world application, it includes the automatic street lighting and where lights turn on or off based on the ambient light level. So this is one of the application that we are using, or we can say that can be the one of the application of our project. So the main objective is to know about the op-amp functioning and know about the LDR functioning. So we are going to know about how these two components work, and also to the simulation software that we have used, that how we have used, and all about that we got to know about it. So that is one of the objective of us. When we see the expected outcome, as I said, we are going to design and simulated the circuit, which includes op-amp and LDR. So we will be knowing the information of regarding it. When we think of the procedure, we can say the first thing is the working of op-amp comparator circuit. So there is an op-amp which is having the two terminal, that is non-inverting terminal and the inverting terminal. So we can say that op-amp operates as a comparator, comparing voltages at its non-inverting and inverting terminals to switch its output. Uh, then the second is LDR, that is light dependent resistor or potentiometer. So the functioning is, we can say that the variable resistor, that is potentiometer, allows us to set the reference voltage at the inverting terminal of the op-amp, and by setting this value we are able to determine the light level at which the LED will turn on or off. So the second is designing the circuit. So first of all, we are doing that on the Tinkercad software, where this data that we have collected after doing the simulation, these are the components that we have used on Tinkercad. So which includes the 741 IC op-amp, photoresistor, potentiometer, resistor, red LED, then power supply,
Hello,
then
myself
voltage
Keshwar
regulator.
Ansarji,
So these are the
PRN
components that we have used with these particular
202301070086.
values.
I am here to explain uh, working
Power
principle of
supply with
our
12
project.
volt, potentiometer
Uh,
with 250 kilo ohm,
Light
LDR with
activated
1 kilo
switch
ohm.
using
And this is
LDR
the
and
basic
op-amp.
layout that we have
So, circuit
got
operation,
from the
discuss
Tinkercad
the
software after
relationship
doing the
between
simulation.
light levels and the
So
LDR
when we have
resistance.
did
In
the
low light,
simulation,
the
we get
LDR
its printout that
resistance is
how
high,
our
leading to higher
simulation
voltage
looks like
at the
as a
non-inverting
layout or
terminal.
as a circuit.
Conversely, in a
So
bright light,
here the you
the
can see.
resistance drops, reducing the voltage. Explain how the op-amp compares this voltage with the reference voltage set by
Here you can see
potentiometer.
there is a power supply,
Detail
then
detail
there
how
is a
the
resistor,
output of op-amp
then
switches
this is
based on
the
these comparisons,
LDR,
where
that
the
is light
voltage at the
dependent resistor. You
non-inverting
can see
terminal
that light is
exceeds
emitting
that of the
on this
inverting
resistor,
terminal.
and because of
The
which
output
the
goes high,
functioning can happen.
turning the LED on. When the
Secondly, this
inverting
is
terminal voltage
potentiometer,
is higher, the
which is the
output goes
variable
low
resistor
and the
amplified with the
LED
variable
turns
resistor,
off.
and this is
So
power
next
supply, this
point
is
is
the
the
ground
simulation
connection,
setup.
and this all
Simulation
connection
environment
are
introduced
here
Tinkercad,
to the
explaining that
the
it is a user-friendly
inverting terminal and
platform
the
for simulating
non-inverting
electronic
terminal of the
circuits.
op-amp
Setting up the
741.
setting up the
And
circuits
at last,
demonstrate the
there is the
process of
LED
building the
as
circuit
a
in
result of
Tinkercad,
this, and also
showing
we'll be
how each
getting to know
component
about
is
it.
placed and
And
connected
this is the
according to
resistor.
schematic.
So finally, this is
Emphasize
the
the
overall
importance
circuit,
of the
and
voltage
we
divider
will be able to
configuration
have the
formed by the LDR and
switching of the
potentiometer,
LED, or we can say the
explaining
light
how it
activated switch,
generates a variable input
whatever we
voltage
want, that has
for
been
op-amp.
achieved from
Simulating light
that, we
conditions,
can say.
changing light levels show how to adjust simulated
Now the
light
further
levels within TinkerCAD.
functioning
You
of the
can do
circuit, or we
this
can say
by
one thing
using the
of the
light
project, and
intensity
the rest of the
settings
part of
available
the
in a
project will
software,
be explained by
explaining that
Keshav.
as you change
So
the
I will invite
light
him.
intensity, the resistance of LDR will change, which in terms of in turn alters the voltage at non-inverting terminal of the op amp. So output behavior is to illustrate the changes in LED state as light levels vary. Highlight the LED illuminates when the input voltage exceeds the threshold and turns off when it drops below the threshold. Use the multimeter in a Tinkercad to show the real time voltage readings for the both input from the LDR and output from op amp. Results and analysis show simulation results. Display the screen. We have displayed the screenshots or live demonstration of the result during the simulation. You could show a side by side comparison of the input voltage from the LDR and the output voltage from op amp. So at the end, we can draw a conclusion. So the circuit successfully demonstrates a light activated switch using an op-amp comparator, highlighting its responsiveness to the light levels and how it functions as a level detector. Practical applications briefly mention real-world applications such as automatic lighting system in homes or streetlights, where such a circuits can be beneficial. Encouragement invite viewers to experiment with the circuit design and explore various combinations configurations to see how they affect performance. Thank you.
Thank you for listening our views on op-amp and LDR based switching circuit, uh, that is light activated switch circuit. So thank you. Thank you for listening our views on op-amp and LDR based switching circuit, uh, that is light activated switch circuit. So thank you.
Thank you so much.